Hello students, I am Saili Rathod from International Center of Excellence in Engineering and Management ICEEM Aurangabad. Today I am here to present a lecture on digital electronics whose code is 204. This is video number 4 and the topics which we have covered in this video are conversion of binary to octal, octal to binary, binary to hexadecimal, hexadecimal to binary. So in this lecture we will see all the conversion techniques in digital electronics, in number systems, and the topics covered today are from the first unit, that is the number systems. So we will move ahead with the next slide. So before going ahead, we will have an overlook that we have seen in the previous lectures. We have seen the different types of numbering systems. What are they? First one was binary numbering system, which includes the two digits, that is 0 and 1. Then we have seen the octal numbering system, which uses the digits from 0 to 7, that is total 8 digits. Then the decimal number system, which uses from 0 to 9, that is the total 10 digits, and the hexadecimal number system, in which we use from 0 to 9 digits and from A to F alphabets to represent the number system. So today we will see the conversion of this numbering systems. So in this slide we can see there are different types of conversions. We have partitioned it into 4 blocks. Why 4? Because in the first block we are going to see the conversion from binary to other numbering systems. Okay, so first one is binary to octal. Here the base is 2 and here the base is 8, means it is the conversion from binary to octal. Then the second conversion is from binary to decimal. So we have written the base as 10. Third one is from binary to hexadecimal, that is base is 16. So the first block, this is only the conversion of binary to other numbering systems. Why we are seeing this types of conversions? Because many times when there is need of conversion, the students got confused about from which base to which base we have to convert. So avoid that conversion. First we will see the conversion one by one, that is from only binary to other numbering systems. Then in the second conversion we will see all the octal numbering systems. They are converted into 3 conversions, that is first one is binary, then the decimal and the hexadecimal. Okay, so first block consists of binary to other 3 number systems. Second block consists of octal to other 3 numbering systems. Now the third block, which consists of conversion from decimal to binary, octal and hexadecimal. First one is from binary, this is decimal to octal. So here decimal is converted into binary, then octal and then hexadecimal. Then the second conversion is from decimal number system to octal numbering system. Then third one is from in the third block we are going to see from conversion from decimal to binary, octal and hexadecimal. And now in the fourth block we are going to see the conversion from hexadecimal, hexadecimal into, first one is binary, then hexadecimal to octal and the hexadecimal to the decimal number system. Here we can see the conversions, we can recognize it from the base. Here we have written the bases to left hand side as well as to the right hand side. So these are the basic conversion techniques that we are going to see today. Moving ahead, here we have seen there is a table which is used to convert the binary into octal and octal numbering system into binary. Here we are using a table which is having 3 columns. Why 3 columns? Because as we know from, if you want to convert if you want to convert the octal into binary or binary to octal, means if you want to convert 2 into 8, then what you need to do is you have to, if you square the number 2 you will get 4, and if you want 8 then you will have to make the cube of 2. So what we have to do, we have to cube the number 2 to make it into octal. So just remember this number 3, and just remember that whenever the conversion is from binary to octal, you need a table of 3 columns. So this is the table of 3 columns. Here 3 columns and there are 8 rows, as it is a octal conversion, octal to binary and binary to octal. The rows are 8. So in the first column we will write 4 zeros and 4 ones. Then in the second column we will write 2 zeros and 2 1, again 2 0 and 2 1, and in the last column we will write alternate 0 1 0 1 0 1 0 1. So just remember this table. Okay, this is from 0 to 7. In the similar way, when we are using the hexadecimal conversions, we use a table which is of 4 columns. Okay, so we will see that in the next slide, next point. Okay, so just remember this table. This is very useful for the conversion of binary to octal and octal to binary. So moving ahead, we will see 8 questions total to see all these conversions. So first question is 761. This is an octal number which we have to convert into binary number. Okay, so base is 8 and we have to convert it into a base of 2, means we have to convert it into binary. So the process for conversion is, first of all, write down the binary number of 7. So from the table you can see what is the binary number of 7. It is 111. Okay, then the second digit is 6. So what is the code for 6? It is 110. So we have written 110. And the third one is 1. So what is the code for that? What is the code for 1? It is 001. So this is very simple technique to convert an octal number into binary number. So this is question number 1, and this is very basic question to convert octal from binary. Now in the next slide we will see again a conversion from octal to binary which includes a decimal point. Okay, so question number 2, convert 71.3 octal number into a binary number. So the same procedure is used here. We have to write one by one the codes of digits. So first digit is 7. What is the code for 7? It is 111. Then the second digit is 1. What is the code for 1? It is 001. And then we have a decimal point. So we write decimal number as it is. And the last digit is 3. So what is the code for 3? It is 011. Okay, so this number is an binary number which is the conversion of 71.3 octal number. Clear? Then let's move towards the next slide. This is question number 3. Here what we have done, we are going to convert a binary number into an octal number. So in the same way we have to use the table, the 3-column table of octal to convert the binary into octal. So as we know, the octal uses 3 columns table. So when you are converting binary to octal, you have to make groupings of that binary number. here you have to remember the groups are made in 3, means you have to made a group of 3 digits. Okay, so the first example is 10011. This binary number we have to convert into octal. So first thing is that you have to make group of 3. We have written 100. Okay, so this is the number 10011. We have to make a group of 3, but we have to move from right to left. So first group will be of 011, first group, and we have only 2 digits in the left, so we have to include a 0. After including 0, we will get a new group of 010. Now we can use the table and write the code for 010. So where we find 010, it is here for the digit 2. So we will write 2 for 010. The second group is 011. So where it is 011, it is a number for binary number for 3. So we can write 23 as an octal number for the conversion of 10011 binary number. Okay. This is the fourth question, in which we have converted a binary number into octal number. Just the difference is that we have used a number having decimal point. The number is 10.11. This is a binary number. So first process is to make the groupings of that number. Now while using the decimal point, while converting a binary number having decimal point, we have to make groups. But remember one thing, that when making group before the decimal point, you have to move left, and when making groups into right of decimal point, we have to move from left to right. Okay, so first group will be of the first number, that is 10, but we have to include a 0 in it, and from to right also we have to include a 0 in it. Now we can make a group of 3 numbers, 3 digits, that is 110 and 010. Okay, now where is 010? It is here for the digit 2. So we can write 2 here. Then we have to write decimal point as it is, and the next 110, where it is 110 is for 6, so we can write 6. It means the 10.11 binary number is converted into 2.6, which is an octal number. So this is the question number 4. Up till now we have seen 2 conversions, that is from octal to binary for non-decimal number, octal to binary from having a decimal number. Then we have seen binary to octal without decimal and binary to octal with a decimal. So we have seen 2 conversion techniques and 4 examples. So moving ahead, this is question number 5. Okay, so before moving to question number 5, we will discuss about this table. Here, as we have converted which binary to hexadecimal, so what we have to do to convert 2 into 16? What we have to do, as for the octal system, we have cubed that 2 to get a 8 digit number 8. So when we want 16, we have to give a power of 4 to 2, so we will get a number 16. So just remember this power of 2. It means we need a table of having 4 columns. So in this figure we can see a table of 4 columns, which is having total 15 rows, means we have to 16 rows, sorry. We are converting a hexadecimal to binary and binary to hexadecimal. So we are using the numbers from 0 to 9 and A to F. For that purpose we have made a table. So here at first we will use the 0 8 times and 1 8 times. Then in the second column we have 4 times 0, 4 times 1. Here 8 times 0, 8 times 1. Here 4 times 0, 4 times 1. Again 4 times 0, again 4 times 1. Here 2 times 0, 2 times 1, and similarly the process repeats, and in the last column 0 1 0 1 till the end of the table. This is the table. You have to remember this. Here we can see that from 10 to 15, the numbers from 10 to 15, they are represented as A to F in hexadecimal number system. Okay, so let's start with the new question. Question number 5. 61 hexadecimal number, we have to convert it into binary number. Okay, so very easy technique is there to convert this. First one, which is the first digit, it is 6. So we will find the code for 6. It is 0110 from the table. So this is the code for 6. Then we will write down the code for digit 1. It is 0001. We will write it here. Okay, so this is the binary code for 61 hexadecimal number. Clear? This is a very easy question. Then after this we will see an hexadecimal to binary conversion, but the hexadecimal number is having a decimal point. So question number 6, it is 8a.d hexadecimal. We have to convert it into a binary number. We will write codes of each digit one by one. So first one is 8. What is the code for 8? It is 1000. So we will write it here, 1000. Then the second digit is A. What is the code for A? A means 10. The code for 10 is 1010. We will write it here, 1010. Then we have put a decimal number. And then the last hexadecimal, that is D. D means 13. The code for 13 is 1101. We will write it here, 1101. So we have converted 8a.d into binary number, which is 10001010.1101. Okay, so we have converted hexadecimal into binary. Moving ahead, question number 7. Here a binary number 101101 is converted into hexadecimal number. So we have to do a grouping of the binary numbers. As in the octal to binary and binary to octal, we have made the groups of 3 digits, but as it is related to 4 columns, we have to make the groups of decimal number into 4 groups. So we will write first the number 1 1 0 1 1 0 1. This is our original number. So first group will be of from right to left, that is 1101. But when we will make the second group, there is a missing place of 2 digits. So we will add 0 and 0. So here we have got the number 00101101. Now from the table we can see what is the representation of 0010. It is here, that is 2. 0010, it is shown here, that is it is for number 2. Let's again come to the question. We are converting 101101 binary into hexadecimal number. So using this table we have made groups of this digit, that is 0010. Here we have included the 2 digits, that is 0 and 0 in the starting, and we have made a group of 4 from right to left, that is 1101 and 0010. Now 0010, where it is, it represents number 2. So we have written here 2, and 1101, it represents number D, that is 13. So we have written here D. Okay, so this is the conversion of binary to hexadecimal. We got the answer as 2D. Then moving ahead, here we have converted a 11.110 binary into hexadecimal. When converting decimal binary number having a decimal point, we have to make groups moving from right to left before the decimal and from left to right after the decimal number. So 0011, where it is 0011, it represents the number 3. So we will write here 3, then we will give a decimal point as it is. Then we will see 1100. What is 1100? It is a number 12, that is C. So we can write here C. It means this binary number is converted into hexadecimal number as 3.C. So this is the last conversion. We have seen four types of conversion total today. Okay, what we have seen up till now, what is number system in the first lecture. Then we have seen four types of numbering systems: binary, which is having base 2, octal, that is having base 8, decimal number system having base 10, and hexadecimal, which is having base 16. Then we have seen how to create a table for octal number. We know that for octal we have used a table of 3 columns, and for hexadecimal we have used a table of 4 columns. Then we have seen the conversion from binary to octal and octal to binary using this 3-column table. And then we have seen the conversion of binary to hexadecimal and hexadecimal to binary using the 4 columns table. So up till now we have studied all this. The next lecture we will come up with new conversion techniques. So let us stop here. Till that, keep studying. Thank you so much.